Welcome to Amberskies. We're coming to the final episodes of this year. Interesting. So we need to talk about that today as well. But first of all, I made some alterations. In ECS CPP, there was actually an error. I'll hold my hand up. I made a mistake. What we had done is we copied in the source index, which is fine, but the first item should be reset to destination index, and we deleted it there. So that fixes a big error. That makes the whole system fail if we don't do that. So that's the failure in the system sorted out. There was a change in the HPP. Yeah. Amended our components type, our static array. Had to amend that. I'll tell you why in a second. But first of all, amend it to a pointer. Just put star in. That's fine. Oops, don't do that. So that's amended. You have to come down and just put brackets around components type and put a star in front of it. That's what you have to do for that one. My throat's now going. Same here. Same here. Great. And just turn that into an arrow. An arrow. There you go. So that's all the changes in the HPP. In the CPP, a lot bigger changes. So we amend it to a pointer, and that does present us with a problem. We now have to type in all of this lot here, because it could be a null pointer, and if it is, we need a new one. We need to put something in there. So that's that part. Arrow. So those are the amendments. Not errors, but amendments. Reason for that amendment. I'll just leave this on screen because it's got all this lot to type in here. Grab me coffee. Come on, Blades. Grab me a coffee. Okay, we've nearly got a throat now. Okay. Reason we needed to do that was because of these things here. We don't know in which order everything down here is going to be instantiated in. So I've got all of these bits and pieces in templates, but we don't know in which order it's going to happen because it's dynamic. And because of that, if we have it as a static array on the stack, then something could be instantiated before this array is available. And that will cause a problem. In fact, it causes a segmentation fault if it happens. So to stop that from happening in C++, we just make it into a pointer, throw it out on the heap, and that means that the stack can use it and put an in place of marker, or just use a null pointer actually. It can use this components type as a null pointer until it gets to load that up, as it were. So that's what changed there. It's not a major change, but it's just a aesthetics change, shall we say. It's not needed, but it will help an awful lot. So that's change is complete. So for the viewers, yeah. And yeah, I said it was coming up to the finals of these episodes. Yes, it is. My job is research and development, and the research part is coming to an end. A year I was given to put this all together. Tomorrow's a big day, Thursday. So tomorrow I'm in a meeting for the future of this channel, really. Whether I can present this to the bosses as something I can do in public, as a developer, to write the full Amberskies code. Remember, it's going to be made public anyway, so there's no problem there. The only problems I've got is that we didn't get any financial support for this. So that's a bit of a downer, but I wasn't expecting any, and I haven't asked for any. So that's okay. That's not a major issue to me anyway. It may be to the bosses, but I haven't checked, have I? Let's have a look. So if I go to PayPal. No, that's a utility. That's no good. I thought that was PayPal for a second. Yeah. Where's my thing? So I have had on the channel. Here we go. This is the channel. So I have had on the channel all these buttons and things here. One is Patreon, and the other one is PayPal. So these buttons I don't think have been used. I'm sure they haven't. I would have got a notification, wouldn't I? I know I'm not very good at this kind of thing, but no, even at $1 a month, it's still not gone, has it? Yeah, patron 0, okay. I can't remember where my PayPal is. It's obviously not on here. So it must be somewhere. Unless it's down here. No. No, because what I want to try and do is place it on the website, on the GitHub code. I want to open up an Amberskies project and make it public, and then Twitch every single moment that we're on there, so you see everything coming together, and can join in, obviously. But it's whether I can get the people support. I'm not really... Okay, I'm not overly bothered, but it's a bit of a negative probably for the bosses. Otherwise, the kind of response I've got from you lot is fantastic. I'm overwhelmed by it. I think it's unbelievable that anybody might be interested in something, well, just me researching for a year. So obviously people are interested in what I'm doing. It's going to be, the proposal is going to be like a web browser, but it's going to be a network browser. For a 3D network is what I need to create. Well, that's a proposal I'm going to put to the team tomorrow. Well, the bosses. If they say it's a go-ahead and I can get basic funding for it, then yeah. I'll also need obviously a computer to do it on. I'll probably try and steal this one. It's alright, actually, this one. I've redone the boss's laptop so it works properly. You can have that, I'll have this. Lovely, lovely, lovely. So plans are in motion for a big meeting tomorrow. On Friday, I'm back with the doctors, so it's okay. It's just a checkup, so I'm not expecting any problems there. Next week, I will be explaining how this ECS works. Today, I'm going to try and finish it. Next week, I'll be Monday now, won't I? Where I start explaining how all of this, you'd write it into a program, how you would do components and how you would do the systems, how you put them together and place it into a program. I'll be using the input that we did a couple of weeks back in episodes 1 and 2. So I'll be using the input from that. So it all fits together nicely. Let's see what else is there. Yeah, I'll be going on I've got a vacation. Obviously, I've been working a year, so I get vacation. So after next week, it'll probably be about the 4th of November if I can get things set up. And we can get the channel. And we can get the backing of Amberskies. Full on. That's going to be the trick to this. And then I'll be a developer. I won't be a researcher anymore. It'll be great. Well, actually, no, it'll be awkward because I'm not the best developer. I don't like doing unit tests, but that's beside the point. Let's get on with this. Systems. We're up to systems stuff, weren't we? What systems have we got? I don't know. Let's have a look. Add components. No. Oh, right. Yeah, it's above here. Here we are. System stuff. Update system's going to be a biggie. We've got add system, so there's only a remove system. Alright, we'll do that first then. Okie dokies. If anybody wants a copy of my notes, by the way, they can have them. They are completing nearly 1,000 lines long now, my notes. Yeah. Gonna put this in CPP. Oh, I've already done it. Hey! There you go. I'm way ahead here. I know what I'm doing, obviously. No, I don't. We want it as a bool, don't we? Yeah. Let's make it a bool. So remove. So we want a success or a failure. Bool. And that means we are going to need a return. Right. And our return will be false. There we go. I say this is easy, but is it? Well, we've really covered all of this already. So it's just going to be straightforward. UN32 thingy, wasn't it? Yeah. So I've got the system. Yeah, we're bringing in the system by reference. So I've already got that. I can then go through the systems and just remove the system. Yeah, let's do that. I equals 0, semicolon. I is less than. It's systems plural. Is it? That one. Systems plural. So we're going to have to go through all the systems to remove it. So size. I++. That should all work. Nope, that won't. That might. That probably will. There we go. That's what it should look like. I think we'll have that. Yeah. We'll just run through all the systems. Let's find the system that we want. So if the address of system is equal to systems I, sub I, then we can get rid of it, I suppose. Yeah. Systems. Luckily, because of the way we've stored it, we can just erase it. There you go. So everything has to be kept in the same order. The systems have to be kept in the order that they have been programmed, as we don't want to break the logic of the game. So there's no moving around to do or anything silly. So it's systems dot, we need the iterator begin, because the silly way this thing works, plus I. Yeah, I know it's a silly way of doing things, but hey ho, that's C++ for you sometimes. And all we do here is just return true. So that's it, we just erase the system. There's no need to do anything else, because we have to keep the systems in the same order. There we are, that's it. Well, that took a long time, didn't it? And now we have the update system. Well, let's see what we're going to have to do there. Now the big one. It's not really big, but fiddly. What are we given? Delta time. Oh, that's alright then. We better create an array then. Let's see, base components, base, ECS components, because that's what we're updating. We'll take a reference of component parameters. That's what we'll call it anyway. Doesn't matter what you call it. Why is that a problem? What are we expecting? Requires an initializer. Does it now? Okay. Alright, it needs an initializer. I'll see what we can initialize it to in a minute. Well, let's find out what else we need. Alright, okay, fine, fantastic. 4. The only reason I want it there is for cache compliance. Oh, we'll see. I equals 0, whoops, semicolon. I is less than a system, again, dot size. I could have just copied and pasted. Silly me. There we are. So it's exactly the same as this bit here. So we're going to go through all the systems. What do we need to do? Alright, we need a const array. You do know that array is just std : vector, don't you? Even though I keep putting array in, because it's easy to work out as an array. You'll see when I do the full thing if I get permission. uint 32, so what we're looking at here, and just get ourselves a component type. Yeah. Component types. This one does need an equals, you're right. So it's systems. I, sub I. Pointing to get component types. What does that take? Nothing. Absolutely nothing. Fantastic. That works. Alright. There's two ways of doing this, so we're going to do both. Yeah, we'll do both. So if component types dot size is equal to 1, so there's only one component. That makes it very, very easy to do. So what do we have to do? We have to make a size t. Definitely. We'll have one of them. So it's size t type size. I'm just wondering why that size t didn't work properly. Why has it gone that colour? Because I haven't saved most likely. I'm not sure it should be that colour. It should be white, shouldn't it? Because it's a type def I'm using. Oh, it's picked it up anyway, doesn't matter. Type size equals base ECS component get type size. We need its size. And it's going, if this is the first, if there's only one component, that's easy because it's components type, component types 0. Because it's the only component we have. So you can see how this is coming together now. Array uint 8. Just call it array. It's a blob of data. Because it's a component, isn't it? So it's components. That's that one. My notes are wrong. Just alter my notes. Yeah, at least I know what I'm doing if my notes don't. That's good. For component types, sub 0. That's the one. So that will give us an array of the memory. That gives us the memory of the components. Right. And the components themselves. So now we can go ahead and update the components. To do that, it's a for loop. Uint 32, we're going to have to use j equals 0, because we've got I, by the way. So j is less than array dot size. So we'll go through all of the components within that array. Yep, j++. Alright, let's do that. So first of all, we'll need the base, we'll need the component itself. So that's a star component. Actually, I'll call it comp. No, I'll call it component. We haven't got it, have we? No. call it component. And that's going to equal cast star. And that's going to be and the address of array at j. So it can loop through all of our components. It can grab the component, and now systems sub I can do its thing and update components with delta time we've been given. And what else do you need? Oh yeah, the component, that helps. But you want double star, so you want address. You want the address of the array, or the component. Ah yes, you want the address of the start of the data. Right. So that's just component. Yeah, and that should do it. And again, my notes are wrong. Correcting my notes as I go through. I knew I should have gone through my notes twice. It saves me correcting them, but that's correct. So that's how you would do it for a single component. Now the fun starts. Else. And this is where the fun really does start. Compone. We have multiple components. Oh dear, what do we do? Well, we could find a corner, sit down and cry. What's wrong with my else statement? Oh, I've put it on the for loop. Whoops. Sorry. It's on the if statement. There we go. So we've got multiple components. What do we do? We make it easy on ourselves by creating something that can do this for us. We're going to create the silliest named thing in the universe because I want to keep it separate from this code. This is our, well, I'm going to use it as a template to do the next part of the code, but I don't want these two pieces of code together in case we need to work on one or the other or both. I think it's better to split them up. So what we're going to do is we're going to create a new method. Where am I going to put it? It's in the privates. Remove systems in the way. Or I could put it here. No, I think I'll put it all the way down here. Stuff it. We'll keep it in line. Alright, let's do it here then. What we're going to call it? Something stupid I said, didn't I? So void, it's going to be update system. and with multiple components. There we go. Can't get any worse than that, can we? We are going to pass into this a uint32 index. We are going to pass into this the delta time. We are going to pass into it a const array of a uint32 and component types. Yeah, will that work? What's wrong with component types? Have we got a duplication somewhere? Nope. Just got one of them missing. So that's component types. What else can we have? Oh yeah. We're going to need an array. But we couldn't have this, could we? Alright, I'm just going to put this on this line then. Array of base ECS component star and this is that param thing that doesn't work. All we're going to do is pass it through. Okay, we'll take you off then. And you can do that until I find out what I'm going to do with you. I know what it's for. CPU cache compliance. I'm sure of it. Yeah. It's looking like it anyway. Alright, so that's the silly thing that we're going to be putting in. Alrighty, let's put that in then. Save. Down to the bottom. Pop you there. There we go, I'm just putting ECS on it. To make it part of the class. Just bury you a minute. Alright, what's our index? Our index is going to be a nice one. We've already got that, it's I. Delta time, we already have. Component types, we already have. And that's all we've got. I do want that param though, don't I? We'd have to set it up somehow before passing it. This is awkward. so the component params. Can't be set up there. Okay. It's just that CPU cache compliance is now being broken. Okay, so we'll take it out completely for now. And let's see if I can do it better later on. See if we can work out a way of doing that. Alright, so notes. Unable to initialize at this stage. So we can't put it in. Great. That's going to slow things down. We're talking 1,000 times slower on that array. In computer terms, that's a long time. But I don't think we have a choice yet. Right, let's write it. Oh, God. It'll work, but... yeah, it'll work. Oh. Wait a minute. I can initialize it to nothing. Oh, God, of course. Let's try it. Let's try it. Come here, notes. Sounds like my notes are wrong again. Here we go. It's this line here, isn't it? That one. I do want to pass it in. The reason is I want it to be referenced before it gets passed in, or it'll take ages to get it into the cache memory compared to everything else, because it'll be doing it every single time in a loop. And that could cause a bit of slowdown. So back up to update system. And it says it can't do it. Can I just do that? It wants the address of a base ECS component. Do we have one? We have this one here. That'll do. I can't. No, it's got to be outside the loop as well. So what I need is, let's type it in. So it's going to equal that star, and it's this here. It's this line. I need the component type. I need that joined with that. I need those two lines. To give me the address. That. So the first part of it would be that. Shift and. Where are we? System. Component types. And it's going to be... Oh, wait a minute, I might be able to do an arrow here. No. I've got nothing. Wait a minute. Wait a minute. Why can't I make this a null pointer? So what did I say? Base CCS component. Okay. No. Must be an L value. Damn it. That's what it's looking for, the word it's looking for, and I don't want to give it. Dereference it? No, can't. It needs to be cast. Oh well, still struggling with that one. Leave it for now. Let's get on with everything. It's going to cause problems. Actually, may not do. Let's try putting it in the other side. Okay, let's transfer the problem down here. And just put a doobry on it and see what happens. Because I need to use that. And I can't set it to 0 anyhow or any way, shape or form. Okay, let's see what happens then. This is what it should read next. So we should have component param. Oh. Let's see if we can do it this way. Equals component param. This is backwards. Dot resize. We'll have to use a maths utility. Okay, include maths. I've got a core maths utility, so I'll use mine. .hpp. Hope I have. No, I haven't. Core. Nope. I should have. And I haven't. Where have I put it? It's there. There it is. So it's math. Math, there we go. That'll do it. That's called the math. You can just include angle brackets math or maths, depending on how it's spelt in the standard library, but I'm only going to be using a standard library function. It's just been hash defined, as you can see. Alrighty, so I've got that. We want max. Math max takes component param dot size, whichever's the highest between that and component types dot size. And that's why we need it. One, two, yeah, that's right, isn't it? Yeah. And it won't let us do it because we're reusing something that hasn't been initialized. It must be an L value. To be an L value, it has to be equal to nothing. Alright, I can't do it this way. This isn't working out. It should just be that. There shouldn't be a problem with it. Let's have a look. Base. CS component star. What's our array? It's that one there I want. And it's got to be the size of an array uint 8. An array uint 8 size. Got it. Now why doesn't it like that? Because that has to be defined as something. Okay. That has to come before this, is what it's saying. But we don't have the component types. Put that to a 0. And it's array.size, isn't it? And array 0. Yeah. That's right. Now, why won't it accept that? No, that's correct. It wants me to make a new one. Oh, damn you. Well. Okay, let's make a new one then. A new array. Base. ECS component. Star. Blah. 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 Oh. Allocate type. Yeah. The constructor fills the vector with default, yeah, which is what it's asking for. You're saying I don't need new? Oh, come on. What the heck's going on here? What have I got wrong? It's not new. Alright, I've got my component parameters. We've got everything in the right places now. Yeah, component types, yeah. And I moved, which one? That one there. Yeah, okay. Jesus. Component param exists. We can now add it. It must exist, otherwise we can't do this. Oops. And we can still pass it by reference. Fantastic. Comma, blah, reference. Thank you, that's all I wanted to do. Alright, that makes this right now. We've got a blank one, it's filling it with the right rubbish. In other words, nothing will go into it. Fantastic, we can do the comparison now, we can do the sizing. So now, I can remove that line. I'm not trying to create it anymore. Now my maths goes. Okay. What's wrong with this now? Comma. Ta-da! It works! Finally, we have component parameters resized to the correct size. Oh my god, that was hard work. Okay. We can continue. We can do our update system with multiple components. Stupid named thing. Alright, let's get back to it. Where are we now? Notes. Oh, we're into the 600s, that's good. So we are up here. Right, okay, size T's. Here we go. Let's get the size. So again, it's the same. Size T. We're just going to get the size, so that's type size, obviously. Notice I'm trying to do this outside of for loops now. So this component parameter has been set up outside of any for loops. So is this type size. Whereas on our original here, everything was set up inside the if statement. That's why I wanted to bring it out. It is inside the main for loop, the else part is inside, still inside, it's going to be done multiple times. But hopefully with everything coming through to a separate function, we'll be able to keep it cache compliant. In other words, we just need to make this function cache compliant and it'll work. Everything can be inside the CPU and running at ultra speed, is what I just said. Type size equals, well, it's going to base ECS something or other, component. Get type sizes in it. It's nothing. Get. Nothing that we haven't done before. There we go, that's fine. And we're going to have to use component types 0 as our base for the type size. Because that's what we've been given. Yeah, that's right. Lovely. For the array of uint 8s for our components, we'll just call it array again for this. It's just a blob of data. It's just the same again, isn't it? Components, open, and yeah, it's the same thing. We're just using that one there. No reason not to. It's the first one, so we can use it. And now we can do the for next loop. Now we've got all the information. And it's uint 32. So as you can see, I'm doing it outside of this bit to try and keep cache compliance within the function. Hopefully the whole function will just happily sit there in the CPU being used multiple times. And that way it'll work a lot faster than you would believe. It means we can do this on the run, and well, we're not going to be cache compliant at the end of the day, but we'll talk about that in a bit. Array size, please, semicolon I plus plus, as before. So we've got our for loop. Right, we're doing it looking good now. So, component param beginning, please, of the component will now equal, and this is what I was trying to put in before, and it's and array, is it I think it is, yeah. See, that's what I was trying. That's what we want this component param for, and why we want it sitting outside of everything, so it doesn't keep getting re-instantiated every time through. It'll be a nightmare if it does. Alrighty, we're getting to some of the big parts now, aren't we? We are going to need the entity component, so we're going to need to bring that out of the parameters. Here goes. Array. It's a standard pair for an entity. std colon colon pair. I think they were uint 32s, weren't they? If I'm remembering rightly. And they had an address. Call it entity components. Yeah. So we'll need the handle to entity, open brackets. What does that need? Just the handle, which is component param 0, still we're working with, and there it is, entity. Fantastic, that's the handle. Nice. I think we'll split that into 2 lines. We can also do that, couldn't we? These are going to be long lines no matter what I do. Alright, so we've now got our component param. We've now got our entity components, which means we can now do it. So we now have to go through each component and update them. Start with a bool. Equals true. Have we got this down as a void, haven't we? Are we going to keep it as a void? Yeah. I think we are. I mean, this is the murder point. This is where it all comes together, folks. The do or die code for uint 32. What are we on to now? I or J? J. J equals 0, semicolon. J is less than component types. Have I done that right? Why have I done it wrong? Oh, it's component types dot size, and it's J++. Nothing spectacular going on there, so we're going to go through all of these components. Right. First thing though, if the first one has already been done, so if J is equal to 0, just continue. We don't need to do that one. But that is going to change later on. Yeah, we'll change that. Again, it's going to be for the cache thing. Cache compliance. Never mind. Component. Which one do we want? Params J. Equals get component internal. Yes, we're going to use one of our internal methods. And it's entity components, comma, component types J. That's it. I've not spelt it right again, have I? No, I spelt it right. Oh, right, okay, that worked then. Fantastic. So that gets the component parameters, or the data parameters, or whatever you want to call them at this state. Whatever's inside the component is now available. So if component param J equals a null pointer, is valid equals false. I don't think that's going to work. Oh yes, it will. Get out of there. Done. Done. We're still in the for loop. If is valid, then systems. We don't really want to be updating a null pointer, that's all we're trying to do with that bull, don't worry. Index, the one that we wanted. Update. Components, delta time, comma, and here we go, it's and component param 0. Because that's what we're using, 0 all the way through, aren't we, for the start of it. That's it. There you go, that's the biggie. And if you found that easy, it is. And with that, the systems are complete. But we do have to, well, I've been mentioning it a couple of times now, but we now have to consider cache behavior of the CPU. Because in reality, it's the limiting behavior of the game. Basically, how many entities and the size of your world is going to be limited by your CPU's cache, and how fast things can be updated using that cache. If it isn't in cache memory, it's going to slow your system down to a crawl. If you're thinking about 150 components and at 60 frames per second, and on how many entities? Average of about 4 an entity, and you could have the limiting factor on entities is about 160,000. Times that by 10. You're over 1 million components. Having 1 million components to update every single frame. So, yeah, the limiting factor is not going to be memory. It's not going to be your graphics card. It's going to be the CPU. All games run mainly off the CPU cache, or what it can get in there, and hopefully we've got that, so it's not too bad. For an average type of game, we're not talking a AAA fantastic, £60 game that you buy from the shop. For an average game, this is fine. You won't see or notice any problems with it at all. But for one component, we actually iterate through a linear array. So if we go back to that single component case, back up here. Here it is. We are going to be iterating through a linear array, hopefully, as long as it hasn't been splattered around in memory by any of our other functions. And we are going to go if, yeah, so we're actually on the single, we're fine. We're only going through that one there. So at that point, so that's the dereferencing that's going to cost the time. So on a single component, we're okay. That is roughly cache compliant. That's the kind of thing that you want to be doing, but maybe not with the double asterisks. Without completely ripping the whole ECS system to pieces and rebuilding it, I don't think I could get rid of that. Not straight away anyway. So this is why we wrote a separate method for the multi-components, so that we could try and get it cache compliant, but it's not. If you have a look at it, we have an I and a J, don't we? So we have I for that array and J for that one there. So that's 2 dereference. That's a double dereference. That's not cache compliant, or cache optimal, should I say. It is nearly, but it's not. If you're going to be using a large world size, then it will be an area of concern. I would advise running tests on your code to make sure that it's not spending most of its time dereferencing arrays in here. If it is, well, then you got a problem, and this has to be changed, and that's why it's in a separate function. So it makes changing easier, we hope. So what can we do? We could do better if you know how, but for now we could do a couple of ideas if this compiles. If it doesn't compile, I can't do a damn thing. Oh well, it was close. Alright, we've got an error. Conflicts with a previous declaration. And this is on ECS system HPP 34. What? How did this not get picked up earlier then? Did it say HPP? Oh right, HPP 21, yes I know what that is, yeah. So HPP 21 we have ECS system HPP. What? $34. That's a destructor. Const standard vector unsigned int. Oh, right. I added something that I shouldn't have done. I was starting to do return flags, wasn't I? Sugar. Have I messed up on that? I was mucking about and I thought I had it right. But it's conflicting. It's in... No. Did I put it into ECS? Was I stupid enough to start doing my flags already? Sure it was in components. Oh, wait a minute. There it is. Enum flag optional. Where's the problem? That's separate. It's got nothing to do with this. I've added that because I'm looking at doing optional components. I haven't added it to anything that should be problematic. But I'll take it out. That flag is not now going to be used. Because I haven't finished my ideas on that. I apologise for that one. That was me messing around in the background. Oh god, what have I done now? Okay, that's got rid of the error. Unused variable type size. Really? On 97? I've got this wrong then, haven't I? We got the type size for a reason. And I can't remember where I've used it. It's for... there it is. Stupid me. There's no point in going 0 to 1, 2, 3, 4, 5, is there? No, that's not going to work. It's quite right. The warning's right. It's me that's wrong. So which function am I in? Update system. Yeah, J is wrong. It's plus equals type size. So that's corrected. I think I've done the same below in the multiple one. Where I've got the type size and not used it. I can't remember now, is it I or J? Let's have a look, see if I've remembered on here. Probably haven't. I think it's I. It is. And that's plus equals type size. So that's 2 mistakes. Well done, me. Try a build again. Okay. Warning, suggest parenthesis. What the heck? 246. Ah. I've put the wrong thing, haven't I? It's another equal sign. Yep, that matters. So we should have a clean build now. If I hadn't been messing around with different ideas. Yes, we have. There you go, clean build. Right. Not a chance, Binary Warrior 76. We have no RIP here. We just have me not typing very well because my fingers don't work. So yeah. Here we go. So that's complete. ECS system complete with compile. Fantastic. We've got a system. What else do we need to look at now? Cache compliance, yes. Alrighty. Minor changes. Let's have a look. See what I've got in my notes for changing around the stuff. ECS HPP. Get component internal. Okay. Get component internal. Here we are. Add components. Was it the first one we did? No. Yeah, it's just down here somewhere. That one. Add flagged that one to add an array. That's not going to solve the problem in on the component side, but it will solve a problem within the system side if I put an array on that. Because it'll mean we'll be able to send the array in to our update systems, but it's not going to be helpful with that. So I'm not really bothered about that one. But it's easy to do. Yeah, I think we can do this. Alright, let's add an array. Entity components, or entity component, whatever it is there. Okay. If I add get component internal. An array. So we're going to need a vector, a standard vector, which I've renamed. uint8. And we pop that as a reference to an array or lump of data, which is what we're trying to cache. So in ECSCPP, that's you done. We now have a problem here, yeah. So it's already flagging me. So here we have to add it. And that is array uint8. Did I do it wrong? I did. Darn it, I did it wrong in the HPP file, didn't I? No, I did it right. Good. Yeah, that's just std : vector if you want to know what it is. So that's there. What do we need to change? We need to change entity component dot second to array. So it's that becomes an array. So it's cached because it's been sent in, and then we can use it nicely there. That would help. And this is getting into components. It won't help that much, but it'll help a little bit for the get components, the get internal stuff. So this affects components. We've got an error in here somewhere and it hasn't shown up yet. Okay. We've got an error down here. What's this here? Oh, we have to add an Adobe. So that's our component types. I'm not sure what I'm going to put there yet. I'll just keep that there for a second. Right, so get component internals bin corrected. Knock-on effect. So in the template class, base ECS get component. Where's base ECS get component? Oh, it'll be up here, won't it? There it is. That's wrong. So this will now be get a component internal, and it's going to be component ID. Yeah. Just add that. That'll do it. Alright, that'll fix that. See if it complains. No, it shouldn't. Alright. Done. Now we can go into update systems, which is this part, isn't it? That's update multiple. Here we go, update system. Alright, okay. This is going to be another one of these awkward ones, isn't it? That's not going to work properly. Array. Uint 8. Or not liking it. Just call it component arrays. Because that's what they are that we're passing around now. Can I just do that? Or will you complain this time? No. Good. We're adding that so that after the first lookup, we know it's in memory. That's the point of that one. And now we are going to have to alter down here. So after this, we're going to now pass through the component arrays. And of course it's going to complain. Alright, so let's change the multi right at the bottom to comma something. How's about array God uint 8, an array of pointers, basically. And an array of pointers. Oh, never mind. It's a double pointer. And it's a uint 8 I want. Otherwise we'll have too much memory being passed around. We'll never get anywhere. Yeah, and what we're going to call it, component arrays. Component arrays. That'll do. And we can add that. to here. So you're happy now. Good. Passing it through to here might help. There we go. Right, tons of additions here. Right. Alright, so we're up to there. Now we have to resize it just the same as we had to resize this. Lovely. This time it's going to be component arrays. Right, I'm not sure about that. That could be a mistake. It's not component types. It is. Alright, I'll leave that alone. We can do a preemptive lookup now. Let's do that. So we can add some code now to do a preemptive on this. And it will be for uint 32i equals 0. I is less than component types dot size. Yeah. Looking good. Alright, so let's do that and get this array set up. It's just... oh, we don't really need brackets. It's just components, arrays, I equals, and component. We should have it down here somewhere. Never mind. And component. Open brackets. Component types. Yeah. I. Sub I. Got it. There we go, that's a preemptive. That's an S. So if we do that, we don't actually need this array, because that does that. We'll argue about that later. Which means that wherever we've used array, we can now use component arrays. Okay. But it would be 0. Why is that a problem? That's why. My bad. I'm getting used to this game. Alright, so if that's correct... Ah, we've got this thing here as well. Actually, can we take the whole thing out? Is it sub I? Hold on a minute. No, I can't take the whole thing out. Think about it first. Alright, yeah. I've thought about it. And that's what it becomes. Yeah. Alright, so is there anything else? No, just got the 0i Joker thing. And the major cash gain. Yay! It comes in down here. Or I was going to put array gets replaced with J. Don't tell me it's an ampersand as well. No, it's not. It's a star. Don't like that. I don't like that. We've only asked for it as an array uint 8 and. I wonder if that was supposed to be a star or not. Let me just check this get component internal. That bit's right. Something's not right. Let me just go back up to it. Okay, cash. No, it's just an ampersand. Okay. Fine. Have I missed anything now? So we have amended. We've got our cash gain. And that should end the first idea. And I've done it correctly. Go for that. My heart stops when I'm just rummaging through randomly doing what I think are good ideas. And I'd like to get them all done today. Alright, the second idea is more complicated. Here goes. I'll take a break before we do the second idea, by the way, but this is... Actually, we'll take a break, then we'll do the second idea. It's slightly more complicated, and it's to do with the entities themselves. We've looked at components, now I need to look at entities. And I need coffee. God, this isn't going to be true, is it? Thursday is going to be meeting with boss for future of stream. Saturday, I don't know if I'm going to be able to do Saturday. Friday, I'm not here. I'm with the doctors. So Friday, doctors. We're on Wednesday now. Saturday, will I be back from the doctors? I'll leave that as a go. It might turn, if I can't get time to do a script for Saturday, I'll just do an XCOM. So, possible XCOM. Because of the timings of Friday being the doctors. Sunday sailing, definitely, 100%. Monday, we are going to use the ECS to build something. A keyboard component or input component or something. And it'll be interesting, to say the least. And it'll also be bloody good. So give me 10 minutes. I'll go and get a break. Grab myself some coffee. And we will do this final thing about entities. And you'll agree with me when I say it. You'll think, God, that's stupid. Of course you'd want to do that. But yes, that's the whole point. Be right back. La 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 la. There we go, some music. Hey, we're back. Come on, come on. There we are. Lovely, 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 lovely. Right, here we go, here we go. Last part of the puzzle. And given a scenario where we have a system using two components, which isn't unusual, and one of those components is used by 1,000 entities, say position, but only 10 of those entities have the invisibility component, say. So would it be, at the moment we would, if the first component was the position component, we will go 1,000 times through the entities to complete the components check. Yet only 10 entities at maximum would be found to have the second component. Wouldn't it be better to go through the 10 entities and just check for the other component? Yeah, right. I think that's an obvious one. So we really want to be looking at the components and seeing who's used least. Who's used least, yes, and going through those components to find which systems need to be updated. So, it's obvious, isn't it? Really, if you put it to those extremes, it's very obvious, but it can happen. It can happen. So where would we start with this? I think we'd start with ECS HPP at the bottom here, and we'd have something like a uint 32. Find least common component. How's about that? It would need a const array of components, I suppose, uint 32s. Passed by reference component types, which we know we have. I think that might be a good idea if we used the least common rather than something that we're going to have to search 1,000 times for, like every component has it. So copy, paste. Let's make a, wow, this is getting to be a big file. We're already into the 200s on this one. So how would we do this? We would have a couple of things we're going to need. Uint min size, size, which is going to equal components. May as well set it to the first component type. So that'll be 0. Dot size. So we'll start with that one, the first one. We've got to C base. Got to do this division thing. ECS component. Get type size. need to know that for component types 0. So that will give us a uint, an unsigned integer. So what we're doing is we're getting the size of the component and dividing it by its size. Whoa. Yeah. Get type size. Right, yeah, so we've got the bytes divided by the number of components. Right, yep, that'll work. That's okay. Whoops, put a semicolon at the end. That'll work nicely. And the index for that was 0, wasn't it? So uint min index equals 0. Alrighty, so that's... And components doesn't like me. Components is undefined. Really? I'm in the right file, aren't I? I've spelt it wrong. I can bet you anything I've spelt it wrong. Alright. I'm going to ignore that one. I think it's just being stupid. Try saving it, clicking around. Nothing. Interesting. Alright. 4. I'll work it out in a second. Uint 32i equals 0, semicolon I is less than, you're gonna never guess it. It's gonna be component types. Yeah, close the 2 brackets. Yeah, did that. Never mind. Component types. So I'm going to go through each one of the components as usual and determine its, well, see if it's larger or not. So size t. Yeah, size t, type, size is going to be equal to, we've done all this before, base ECS component, get type, size, and it's going to be component types I. Yep, looking good. And then we need to know the number of components in there, which is a uint 32 num components equals it's not giving it. Why not? Oh God, look what I've forgotten. ECS colon. That's why. Right, it'll work now. Oh, so components, component types I. Yeah. Is this getting silly here? Yes, it is. But component types, component types I. Dot size divide. Oh God, what did I do there? What's going on? Caps lock, get off. size. That's better. And we have to divide that by type size. There we go. That's it. So number of components divided by the type size will give us really how many times it's been used type of thing. Anyway, that's beside the point. No, that's the end of that bit. So if we can do the check num components is less than or equal to min size, then obviously min size equals num components. Not very difficult. And min index equals, well, wherever we are in the I area. And at the end of it all, we just return min index. Yeah, that's correct. Lovely. That works. So find least common component will end up being a min index. Lovely. I like that idea. Now we can alter our update system with multiple components, which should be here. So where do we want to add it? After our for loop here. We can pop it in here, I think. Yeah, that'll do. So uint 32 min size index equals find least common component. It wants our component types. That one. Semicolon. We can now take this min size index and use it. We can put it in here, where we've used component 0 as our base. We can paste it in there. We can, well, yeah, it would go in there if that was alive, wouldn't it? No, it's, yeah. That'd be a star. Do I have to change that other one? Type size. No, that's going to be fine. Yeah, why isn't that a star? I'm using components, and it's going into that array. And it says that a star is wrong. No, it's not. It's component types. That's better. Yeah, that's correct. No, there was no star there. I don't want to put a star there. God knows why. So that's what that would look like if it comes back. Would that help us? Well, it helps us here. I'm just trying to clean this up, because that would then be correct. Yeah, I'll pop it back in there. Why is array not allowed? Oh, that's right, yeah, because it's a dot. Yeah, I think I prefer that. It's shorter, it's more precise. And we've got a min index being used there. What about this next line here? This is looking a bit of a nasty piece as well. Yeah, I'm putting it back to array. Because I don't need that 0. That brings it into compatibility with the min size index as well. Yes, I prefer that. Anything else? Yeah. I've got this one here, haven't I? Oh. It's just a 0 I want to get rid of. Okay. Yeah, I think we're going to be alright with that one. It's getting a bit long though. Bring you back. Pop you over. Alright. Right, okay. And what have we got down here at the bottom? Alright, I corrected that already. And this is why this line was in. Yes, I remember now. Finally, I get to use that line. It's j equal to 0. But now we just don't want it to sort of like compare it to it or do itself. Mess itself up. Right. I think I've captured everything there. Compile. Oops. Control B. Done it. We have done it. We now have find least common component integrated into our multi-components update system thingy. That will make it a lot shorter, an awful lot shorter. Still got a problem with that, which I don't understand. There's a possible pointer conflict on that line. And I can't work out which way it's supposed to be. I think that's the correct way that I've got at the moment. And it's compiling alright, let's just save it. B, compile. It seems fine with it. Doesn't mean it's right. It just means it understands what it's supposed to do. Whether what we've told it to do is correct or not is a totally different matter. But I think I'm done. Right, so I'm going to go and clean up the code. And And the next video will be how to use the ECS. Wow. That was a journey and a half. So it did take 2 weeks, but only because I've got meetings and stuff coming up. Which is a shame, because I could have finished it all this week, but and got on with getting everything ready for the 1st of November, and then done a special on the 1st of November to open up Amberskies, but I'm not going to get a chance to do that now, because I do have to take some time off. I get shouted at for not doing that, you know. Say, oh, you'll burn out. No, I won't. I'll just keep having fun, which is exactly what I do. Nice cup of coffee. Have we wrecked our program? And the answer is... nope. Might change that around though. Look at these controls, are all wonky. I want WS as in and out rather than up and down like that, really. Yeah, it's a bit grotty on this machine, but we will be using a new machine when I start the next one. It'll have a few more processors than this thing. I'm going up to 6 processors on it and a bit more memory. But it'll still have to be in a virtual environment like this. Which is the way to do it, otherwise it becomes a target. Yeah, we were still hitting 60 FPS though, even with me messing about, so it's not doing too bad. It's doing rather well, considering it's on a virtual machine that doesn't exist, with no graphics card at all. There's no OpenGL graphics card on this at all. It's got an interpreter, that's all. It's got like a basic interpreter for OpenGL on here. So it's working nicely on that, surprisingly. But this is going to be murder to do. It will have to be on a new machine. There's no 2 ways about it. Won't be able to use this stuff. Which reminds me. Final updates and tweaks to ECS builds but not tested. That's what I mean. Builds but not tested, and it's that line that has to change. It's no good in building something if it's not tested, according to my boss. So that's the way it's going to be. We've got all the files, we've got everything we need. We will not be using CMake, we'll be using QMake. That's a given. It will be a library and not just a program. This will be turned into a library. Let's see, the main program will be separate. It'll be a client, not a client, but a browser. A 3D browser is what we want to make. And I haven't decided on the base. The basic tools, as it were. I will probably be using code because I can't seem to use anything else. If you've got any ideas, pop them below in the comments. If you're watching this on YouTube, let me know what your ideas are, and that'll be fine. What kind of things I should use? I think we'll probably go for SFML. Reason being, let's just get rid of this. And I can use Firefox here. SFML, let's have a quick look. It works in a lot of things. I mean, I've had a look at the tutorials, obviously. We've had a look at SFML. We're programmed with it. But it does have a network module. And that's a biggie. Because we're doing a browser, we're going to need that. Audio we're going to need. Graphics, we have 2D and OpenGL. We've tested those two. It works. Handling time, threads, user data streams. Fine. That's everything that we need is literally in here. Visual Studio Code blocks, Linux. Well, doesn't matter for me. I know how to do it. That ain't a problem. So yeah, I think that'll be good. Why is that so small? Strange. I think we'll be alright with that. Yeah, I might put that down. But we'll see. We'll see. I got to sit down. I have 2 weeks off. In that time, I'll probably sit there dreaming and designing it, which will be nice. A bit of relaxation for once. I like doing that kind of thing. But I can't come to work and sit here and dream on stream because it won't work, will it? And I am hoping to use this machine, but it will have to be a fresh one with nobody else's rubbish on it. Alrighty, so update if you don't know. Let's get the notes up. Stickies, here we go. I'm not going for a coffee. Alright, here we are. What have we got? Electron, yeah, done that. Talked all about Electron and that kind of rubbish. Alright, so Thursday is the boss, meeting with the boss. Friday is the doctors. Saturday, I'm loath to drop the stream. If I can get a stream up on the learning to program, I will. I prefer that over doing a game. It depends if I get a chance to do a script or not. If you want to know about the scripts, yeah, how to use the ECS 953. Yeah, this is the script here that we've just been through. So this gives me all my handy notes and information, but it's not always correct, as you've seen. So yeah, that'll be part 9, Monday. So that is promised now for Monday. That's a dead cert. That will happen. When can I write the script for it? It's going to have to be whatever remaining time I've got on Saturday night and Sunday morning. I'll do Monday script. I'm not cancelling Sunday. It's too good. It's too much like fun. And I wouldn't mind playing XCOM, but hey ho. We'll see. I might just be able to write that script tonight, actually, for Monday. We'll see. We'll see. I promise you on Monday I will show you how to use this ECS. How about that? In the meantime, I'm away till Saturday, obviously. So I'll be back, hopefully, with learning to program on Saturday using Java, aren't we, on Saturdays? That's turning out to be interesting because we're doing a rendering. We're doing the rendering mechanics and stuff, aren't we, at the moment? And we're using unit tests on it, which I really could do with some practice on. So yeah, I'm going to be needing that. I need a unit test system for Visual Studio Code, so I've got to find one of those as well. I'll probably use Google Test. That's the one that I think is portable, but I don't know how portable and how Linuxy it can be. I'll have to look up a Linux one and see if it is Google Test or not. G-Test. I think we can use it. Oh well, we'll see. In the meantime, take care. Keep dreaming of building that program. Keep programming. Just keep researching. Keep programming. Keep driving yourself towards the final goal, whatever it is for you. It's going to be a good one. So, take care and have fun.